Hello, everybody. Welcome back to the show. My name is Cameron English, Director of Biosciences at the American Council on Science and Health, joined again by Dr. Josh Bloom, the one and only Director of Chemical and Pharmaceutical Sciences at ACSH. So nice to talk to you all again. Josh, it's great to hear your voice. It's been too long.
Were you expecting like two of me? I don't understand this introduction.
I'm just telling people how special you are and that you as an individual are unique and you have a lot to offer the world.
All right. Whatever you want, you're not going to get it, so you can drop this act.
Josh is such a New Yorker, and I love it because I know I can provoke that reaction if I say fluffy, snowflakey things to him because he just says, shut up. So anyways, let's get into what we're actually talking about, which I think Josh will be a little more enthusiastic about. And that's, of course, our two dispatched stories for the week. So first one is one that Josh wrote, and it's called Paxlovid Doesn't Prevent You from Catching COVID. Here's why that's good news. And then we'll wrap up with a story that I wrote about a really goofy article in the Epoch Times about the dangers of glyphosate, everyone's favorite weed killer. But Josh, let's talk about Paxlovid first and tell us a little bit about the story. Sum up what you're talking about here.
Well, I've written before that Paxlovid, which is really the only drug that works now against COVID, and I'm not going to go into ivermectin. I don't even discuss it anymore. Okay. How it needs to be readily available to people who need it. And if that means bypassing the physician and getting the drug from a pharmacist upon a positive test, I've actually written opinion pieces on why that is probably a good idea. So it's really it's almost miraculous how this works in knocking down COVID. People will catch it. They'll feel like death. They'll take it, and 24 hours later, they'll feel better. So this is our only weapon against Omicron COVID. It's not even clear that the original vaccines are doing much. So, and there's no other drug that's any good. So that means we need to protect it. And when I say protect it, I mean protect it from the virus becoming resistant to it, which is one of the things that viruses excel at. They are absolutely just beautifully engineered to generate resistant strains. In fact, back in the days when I worked in antivirus research, the definition of an antiviral drug is one that causes mutations and resistance, which is kind of seems kind of backwards, but in fact, that's how you strictly define or improve an antiviral drug. You can ask a question about that because you probably don't understand, but because it's like, it's going to be too tough for you. But go ahead anyhow.
Well, I wanted to ask specifically about this study that you're writing up, and this was a clinical trial that Pfizer conducted, I believe, to find out if Paxlovid could be used prophylactically. And the media and even the press release from the company seemed to say that, this is unfortunate, this didn't work, and we're disappointed. But you said this is actually good news because it's going to effectively reduce the number of people using this, and this is going to help preserve the drug's efficacy. Is that basically what you were saying here?
Yeah, exactly. The trouble with monotherapy in antivirals is that you're basically begging for resistant strains to be generated. I can explain this in something resembling English later if you'd want. But if you take a look at some of the the most important viral infections, that would be hepatitis C and HIV. It's we learned a lot about how resistance works and how to prevent it. And the way to encourage it is to give a single drug, because then you're going to see mutants forming pretty quickly, and all of a sudden you got resistance, much like what happens with bacteria and antibiotics. So the best way to get around that is to give two drugs that work by different mechanisms. So that really makes it a tough chore for the virus. So it's got to mutate in two different places and also be an effective virus. And this is very difficult. So that's the ideal way to shut down or slow down drug resistance. But when you only have one drug, that's not an option. So by far the best strategy is to use as little of it as possible. Now, that may sound like I'm conflicting what I've said before, that people who need it should be able to get it immediately. But they're really not conflicting statements. And what I'm saying here is that people who are not infected should not be taking it, because the last thing you want is to have extra Paxlovid floating around in the viral universe, and then you're looking at a faster development of resistance. So, in fact, the study that people were complaining about showed that if you gave the drug to people in a household where there was at least one person with confirmed COVID, it did not prevent the others from coming down with it. In fact, it shouldn't. And I don't want to go into the mechanism about why. I think it should have never worked in the first place. But the fact is that it didn't. So what this is going to avoid a certain amount of people who are either hypochondriacs or just plain scared from taking Paxlovid in advance just because they might catch COVID. And well, maybe that increases the amount taken by 20, 30, 50% or doubles it. That's all bad. You really don't want this stuff being taken any more than is absolutely necessary.
Now, I sensed a shift in tone from some of your previous articles about this drug, and maybe I'm reading into this, but it seems like in the last couple of months you were more enthusiastic about the efficacy of Paxlovid, and you seem to focus on the fact that it targets a part of the virus that's much more conserved and it's less likely to mutate relative to the spike, which is what the vaccines target. And that's why primarily the vaccines have lost some of their efficacy over the last year, is because the viruses mutate like crazy. And so the vaccines are not really engineered to keep up with all of these mutations. So are you still confident that the drug is going to remain effective, provided only people who need it take it?
I'm confident that it's going to be effective for a while. Fortunately, there's been no evidence of mutations at the Paxlovid binding site and the protease enzyme, but that's just a matter of time once enough Paxlovid is used. But we're actually talking about two different things. Fortunately, the protease domain is stable. In fact, the original SARS and the current one have basically the same structure in the protease. So it was conserved, meaning that it didn't mutate in the absence of any kind of drug. Whereas the spikes mutate like crazy, and there's no drug involved. It just does. But there's a difference between a conserved portion of an enzyme when it's just out there on its own, or when you start hitting it with drug, because the drug then it begins to pressure the virus to produce a protease that doesn't fit the original inhibitor. In other words, that's the definition of resistance. So, and this can be done very simply. Let's just use your hand as an example, and you glue a bunch of little cubes, circles, and pyramids onto your hand, and then squeeze a ball of clay and take it out. And the ball of clay is the inhibitor, it's the drug. And the protease is what's in your hand. Now, once the protease active site is exposed to Paxlovid a lot, those viruses will not be able to replicate. So just by the sheer numbers of mutations that happen, one mutant is going to emerge that has just a small change. So one of the circles or cubes in your hand changes to a pyramid. And of course, the cubes and the circles and everything I'm referring to are amino acids. And all of a sudden, it doesn't fit as well. And maybe then another one changes, and maybe it doesn't fit at all. And we know this going back to hepatitis C research, where they looked at the composition of protease and mutated proteases for people that were and weren't treated with telaprevir, which is a protease inhibitor for hepatitis C. And they saw exactly one amino acid change from valine to cysteine in one place in the active site. And the result was a 5 to 10 decrease in the potency of the inhibitor. So that's the quintessential example of resistance right there. So just by sheer numbers, the active site mutated, and it happened to stumble across a mutant where one amino acid changed. The drug doesn't bind as well, and therefore that particular strain takes off and becomes dominant. So, that's resistance 101. And I think I'm hoping we can distinguish between the difference of spontaneous mutation in the spikes and drug-induced mutation at the active site, because they're quite different.
Well, let's do that real quickly as we wrap up here. So, and again, just fill in the gaps here. So, as long as the virus is circulating out in the population, you're going to see the sorts of mutations that we're seeing, right? There's going to be new variants, new subvariants, and this was the primary concern for the the vaccination campaign, right? And I think what you're actually talking about is if you bathe the virus in a drug like this one, then it's just inevitably going to evolve resistance to it. So I guess it's the source of the selection pressure. Is that the difference? That
Exactly. Well,
okay.
The selection pressure for the spikes, it's not really selection pressure. It's infectivity, because we're seeing one more infectious subvariant after another. And these things are happening so just on their own. It has nothing to do with a vaccine or a drug or whatever. It's just happening. Whereas if you use a drug and you've got selective pressure coming from the drug, that's quite different, because that's being controlled by giving someone the drug. It's not happening spontaneously, except maybe on a very low level, and that particular mutant wouldn't have any cause to then dominate over the other ones. So it's similar but different also. And this worries me quite a bit, because if we've got drug-resistant protease in these COVID viruses, we're going to have nothing to treat it with. And it's really, Paxlovid is the only thing, and this is my opinion, that is keeping COVID from becoming terrifying again.
Well, we do have a few other, I guess just in theory, maybe, we have other treatments. So there are multiple monoclonal antibody treatments. And from what I'm looking at from the NIH right now, not all of them are effective against Omicron and the subvariants, but I believe 2 or 3 of them still are. And then I know you've written about molnupiravir and how it's not nearly as useful as Paxlovid, but it still has some efficacy, right? So at least in theory, between these different treatments, we have multiple ways to attack it. What am I missing there?
Well, the 3 monoclonal antibodies that originally worked against the Wuhan strain, 2 of them didn't work against Omicron. So you're down to 1, and just if I had to guess, I would say that as Omicron keeps mutating, you're probably going to be down to 0 before long. And as for molnupiravir, it's just a bad drug. It's not effective enough to use it and have any confidence that's going to keep you out of the hospital. And there's nothing coming up behind these, as far as I know. So all the more reason to be super careful with distributing and prescribing Paxlovid. It has to be done very carefully.
All right. Well, there you have it. From a chemist who knows drugs. Don't take it unless you need it.
And, not going to hurt you. Don't get me wrong. It's not harmful.
No.
It's that this is a population-wise public health kind of, want to call it a crisis. It may be. I don't know yet.
Yeah, we'll just have to wait and see. Looking back on the last 2 years, trying to predict anything just seems like such a stupid idea at this point, because you just can't. There's, the things that have happened, there's no way anybody could have known. And I think you can clearly see that if you go look at what people were saying in the middle of 2021 about masking and vaccination. Just everybody was just so wildly off. So we'll leave it there, and we'll just try to, I guess we'll just encourage people to be careful, Josh. But let's talk about this story that the Epoch Times published about glyphosate. And I don't read the Epoch Times. I generally avoid the mainstream press's coverage of pesticides or any kind of food safety issue, because it's just generally bad. I'll read it to, supply our readers with, good information, but I don't rely on them for any information about pesticides. And this story illustrates why. And this was brought to our attention by one of our readers. And by the way, if you send us articles and ask us to comment on them, we will sometimes. If it's something that needs to be addressed, we will definitely take it on. Or at least I will. I don't know if Josh is a little more hardened to that after all of his years of dealing with the media's foolishness. But this was a story written by a holistic nutrition counselor, which I have no idea what the hell that means, Josh. Maybe it's...
I do know, actually. It's roughly equivalent to a decertified yoga instructor.
Yeah, I don't know. And don't go to just my suggestion. I'm not going to give suggestions. As far as I'm concerned, if I needed help with diet, I would go to a registered dietitian or my physician. I would not go to a holistic nutrition counselor. But that's a topic for another day. So this is this woman. Let's see, what's her name? Melissa Diane Smith is her name, and she's writing for this newspaper. And the article is called "Saying No to Glyphosate in Our Foods and Environment." And she just makes a handful of really silly points that we've refuted a million times. But as I said, people come to us and they want answers, so we're happy to supply them. So, Josh, I just want to go through these in the order that I refuted them in the story, and then I'd want to get your comment too. So she starts with this claim that of all the pesticides in our food supply, the most concerning to consumers is likely glyphosate, which is, of course, the primary active ingredient in Roundup, which is, Bayer's big brand of weed killer. And there's dozens of other ones because the active glyphosate is off patent. So anyone can use it in their products now. But what drives me nuts about this, for one thing, is that the fact that consumers might be concerned about something, that in itself isn't proof that more people should be concerned about it. It's an appeal to popularity. It's a fallacy. It doesn't make sense as an argument. But then secondly, and as you and I discussed off air, and we both wrote articles about this, our old friend Carrie Gillum, who is, one of the probably the best known anti-pesticide activists in the world these days, she wrote in a blog recently that most people don't know about glyphosate, let alone have any concern about its health, its effects on health or the environment, because people have real problems to deal with these days. So I think just at the very beginning, she starts this story with an enormous fallacy. What are your thoughts?
Well, I find it somewhat disturbing that one of them is going to be right. I mean, if you think about it, either Melissa or Carrie, neither of whom I'd believe if they told me my face was on fire. Somebody's going to be right about this. It's just something inherently disturbing about that. I thought I'd never say this openly, but I think Carrie Gillum is right in this case. And maybe the conclusions that they would draw from that observation are wrong. The biggest being, I wrote about this in another story, the reason people don't care about glyphosate is because it doesn't do anything to them. That all the data we have suggests that it doesn't cause any serious disease, cancer being the biggest, NHL more specifically. We have no data on that. And so in this day and age, and as we just discussed, there's a deadly virus still floating around, and there's inflation, and there's war, and people have real problems to deal with. And so it's just fascinating to me that these people, this upper crust of wealthy activists that reside primarily in the US and Europe, they have all the time in the world and apparently the money to just freak out about pesticides that don't cause any harm. I think that's kind of amusing. Where do you think the money's coming from? Well, we know in some cases. So we know the organic food industry supplies a lot of the funding that goes into the marketing campaigns and the political lobbying. That's definitely a part of it. Another part of it is you just have really wealthy foundations, billionaires. They either die and they leave a bunch of money to different activist causes that they cared about, or their families do. Someone dies and then someone takes over the family nest egg or whatever you want to call it, and then they just pour into these different groups, which I don't know. I mean, people can do what they want with their money, but when they give it to these really harmful causes, it drives me nuts. Well, here's a question I've never heard a satisfactory answer to. Groups like NRDC and EWG they've become focused on trace chemicals in human urine. That's all you see. It's whether it's BPA or phthalates or glyphosate. Um, it's with today's analytical techniques, you could probably pick up anything in everyone's urine because you can pick up 1 part per billion. So it's so little that it's irrelevant. It's just like it wasn't there. But what I don't really understand is why are environmental groups measuring urine? That's a health concern or a phony health concern. What does that have to do with the environment? Well, uh, let me take a guess that NRDC and all these other people are funded by Whole Foods and Stonyfield and all these other guys because they can make people scared about all these chemicals that are in our urine. All of a sudden, they'll be buying organic this, that, and the other thing, which have no chemicals, which of course is a bunch of nonsense too. So I really find it intriguing that like NRDC, which really does some very good work on environmental issues, is dabbling in chemistry and biology issues, which they absolutely know nothing about.
It is. It's a bit frustrating, and I always say that I really don't know people's motives because people throw that accusation against us all the time. We're corporate shills. We're whores for Monsanto, this and that, which of course is not true. I can speak for myself. I think Josh would say the same thing that he's going to say what he wants, no matter what the number on the check is. So
the number on the check is disturbingly low. And, there's plenty of evidence that, we get, I don't even know what if there are any companies funding us, but it's like pitifully small. And you can see just going to 990 forums with some of these big environmental organizations that they're heavily funded by groups that benefit from chemophobia. So I don't care whether people say that we're industry funded or not. It's just wrong, and we can prove it. So too bad.
Too bad indeed. Well, that brings up an interesting point, and the author touches on it in the story because this point you're making about detecting trace amounts of glyphosate in urine or whatever chemical, whatever bogeyman we're supposed to be scared of, this usually stems from finding traces of the chemical in food. And so she writes, residues of the well-known weed killer have been discovered in a wide range of staple food products sold in grocery stores, meaning we are all at risk of inadvertent exposure from the foods we eat. Now, this is just outrageously stupid. Let me briefly explain why. Traces of pesticides are not discovered, in quotes, in food. The EPA mandates that pesticide manufacturers conduct studies. They have to do field trials to see how farmers can safely use the product. And then they have to conduct laboratory studies where you basically try to poison rats with the chemical because you're trying to find out at what dose or what human equivalent dose would be harmful to humans. So you figure out what harms a mouse or what causes some sort of biological effect in them. And then you set a dose that's like 10 or 100 times, maybe even 1,000 times lower than the dose that causes any impact in a lab animal. And so based on that, the EPA and the manufacturers as well, they know that a certain amount of the chemical is going to be in the food supply, but it's such a small amount that it can't possibly cause any harm. So I don't know if she knows this. My guess would be she might not, given the way she's talking about this. But the point for everyone else listening is that no one discovers chemicals in food. It's not a shock. If you were to ask a toxicologist or talk to a chemist like Josh, they're not going to be surprised to say, there's a little bit of pesticide in your food. This doesn't blow anybody away if they know what they're talking about.
I would challenge the word discover and I would say specifically looks for. It's not like there's some great revelation that there's a little bit of glyphosate anyplace. You can look and find it, and so what? I just looked up the LD50 of glyphosate in rodents, and yeah, I've written about this before. So I knew that the stuff is like really non-toxic, but it's 5.6 grams per kilo of body weight. So that's an enormous dose. Something that basically you could, the only way that you could kill a test animal with glyphosate would be to pack it into a bullet and fire it into the damn thing. I don't even think that they could give enough orally to even kill animals. So the stuff is non-toxic. If you take a look at caffeine and Tylenol and aspirin, these things are hundreds and thousands of times more toxic than glyphosate. So, this is an old ACHH adage that the presence of a chemical says nothing about any harm or lack thereof. It's all about dose. And the dose to even potentially harm anyone with glyphosate is so far away from whatever tiny amounts are being found either in urine or in food that I don't even know if that number exists.
I do know, after looking at the literature on this over and over for these stories, that to cause any harm in any kind of a lab animal with glyphosate, you have to give them thousands and thousands of times more of a dose that's acceptable in humans. So, and I mean, and the conditions under which they're given it are just absurd. I mean, like if you stick a tube down an animal's throat and you pump it full of some chemical, whatever it is, that's not what the rat is meant for, right? Right. Just, I mean, it's an animal just like us. And so it needs to take in certain nutrients, and there are certain things that are going to sustain it and keep it healthy for, however long it's supposed to live. But I promise you, shoving it full of a weed killer in a contained environment, that's not good for it. Now, that doesn't mean the chemical itself is harmful, and that's the point you were just getting at. But the point is, it's like, I don't sit in a cage and like sit in a tub of glyphosate, or I don't mix in glyphosate with my water and then sip it throughout the day. No one does that. So it's not that those studies don't yield useful information in some cases. It's just that you have to be aware that you're setting up a design that doesn't really reflect the real world. And you have to be careful about trying to translate those results into your daily shopping routine, because you're going to get something that doesn't really match your experience or isn't really relevant to your health.
Well, who has to be careful?
Everybody.
Scientists have to be careful, but people who are trying to scare you about glyphosate don't have to be careful. They just have to say it's there without indicating that it can't possibly harm you at that dose, or even 1,000 times that dose.
Well, let me give you a concrete example. And this is actually from Smith's article, and she's badly abusing the research here. So she writes, exposure to glyphosate is linked to reproductive disorders, including birth defects in children and fertility problems in adults. A 2018 study suggested that glyphosate could be associated with shorter pregnancies. This is the example she gives. Let me encourage everybody, if you ever see someone make a claim like this in a popular news story or in an article somewhere, if they don't provide a reference, that's a red flag. But if they provide a reference, click on the link and go look at what the study itself actually says, because I'd say it's probably, there's an 80% chance that the study does not say what the person claims it says. And in this case, I actually went and looked at this study. It was an epidemiological study. It involved 71 women from Indiana. And as Josh was talking about urinary glyphosate levels earlier, all they did is they had these women pee in a cup, and then they asked them how much glyphosate they might be exposed to. So you have self-reported data compared to glyphosate in urine. Now, from what I could tell, none of the women were exposed to amounts that would be harmful. And again, that goes back to the point I made about the EPA setting regulations that limit how much consumers, even farmers, are going to be exposed to. But then in terms of the outcome that she's talking about, shorter pregnancy length, there was no evidence in the study that any of these women had anything wrong with their pregnancies. The children didn't have birth defects. There were no fertility issues detected. And the research were explicit about this. They said, we didn't investigate these outcomes. Now, presumably, if this had occurred in any of these women, they would have reported it. But nothing happened. And then just one final point, and then Josh, if you have any thoughts, you can jump in here. In the discussion section of the paper, they basically say the evidence for elevated risk of adverse reproductive and developmental outcomes is, quote, limited and inconsistent. So they're summarizing their results, and they're saying, look, this is preliminary. It's a small study. You can't generalize from such a small sample size. And this is a problem that you see in other research in this field. And this is them talking. I think there's been something like 6 or 7 studies that have looked at more or less the same sort of outcomes in relation to glyphosate exposure. And they disagree with each other. They have these methodological problems. And so for Smith to say that research shows that glyphosate is linked to birth defects is just an outright lie. Either she's just a very sloppy writer and researcher, or she's being dishonest. And I don't know which it is. It doesn't matter. But it drives me nuts. And especially since becoming a father, this makes me so angry, because there are people trying to make decisions about what they're going to feed their kids, and they're trying to be the best parents they can be. And then you have schmucks like this writing in popular news outlets talking about birth defects and how this shows up in your food, and there's really nothing you can do except to buy, the extra expensive organic bananas. And this is just not borne out by the evidence. And I don't know. I just want to slam my head on my desk when I hear this stuff, Josh.
I could help with that.
But slamming my head on the desk or helping me freak out less?
Well, the slamming the head on the desk sounds like it might be fun. This is your typical junk science. I mean, clearly the reporting was ridiculous, but there was nothing to report on, because the way that was set up, no matter what the result, it wouldn't mean anything. It's a small number of people. They don't know how much glyphosate they've been exposed to. What are they just guessing? So I don't even know how they can tell. They probably said a lot or a little or none, and maybe have no idea whether that's even true or not. And also, the fact that it's in the urine means that their bodies are working properly. It's not in their blood, it's in their urine, which means whatever tiny bit they've ingested is being metabolized and excreted. So your liver's working properly is what that means. So you're disposing of foreign xenophobic chemicals, whether they're from natural or synthetic sources. That's what your liver does, and it's working. So I would argue that presence of a chemical in urine could either be good news or bad news, and is probably no news.
That's absolutely true. And you brought up an important point. As we wrap up here, I want to just make this clear. There has been, I don't know, probably hundreds, maybe even thousands of studies at this point that have investigated a mechanism by which glyphosate could cause some sort of reproductive toxicity, and nobody can find it. So in these studies, what they do, and again, I mentioned it in animals, is they will give them sometimes 750, 800 times higher dose than what's allowed in humans. and then they try to find an effect. And sometimes they do, like they'll find reduce sperm count in rats or something like that. But then someone else will do the same study, or they'll give the rats even more glyphosate, and they can't reproduce the result. So even at these enormous doses that are unrealistic to the nth degree, they can't consistently show reproductive toxicity. So you don't have a mechanism, you don't have a dose at which you're going to consistently get this result. And then of course you have the 40 plus years that glyphosate has been on the market, and that farmers have been using it and consumers have been eating food that's treated with it. And there's nothing that would suggest that there's a problem here. So that's all I've got to say. This is a fiction. These people keep spinning it, and I think they're getting more desperate, and people don't have to worry about it.
I should just add what else you don't have is any statistical confidence that the numbers mean anything at all. With 71 women in different urinary concentrations, there's probably no statistical significance whatsoever, and this is never reported either. So if you've got your contradicting rat studies showing more sperm, less sperm, polka dotted sperm, it could very well just be that the experiment was not set up in a way to gather data that would mean anything. So that's just one more flaw that you can add to the pile that you've already put together.
There it is, added to the pile, a dozen reasons why Melissa Diane Smith needs to stick to holistic nutrition counseling, whatever that is, and quit talking about pesticides, because she doesn't know what she's talking about. For that, come to us, because that's what we do. But we'll leave it there for the day. Josh, thank you again for joining me. It's always such a pleasure to chat with you. You're so friendly and uplifting.
Of course it is, Cameron. I mean, yeah, no one's ever said otherwise, except now and then.
All right, guys. Well, if you want to get the articles that we're talking about, go to our homepage, acsh.org, click the subscribe tab, punch in your email. That will get you on our dispatch newsletter list. You'll get the emails weekly. And then when you show up to listen to this podcast, you'll know what we're talking about. So until next week, when we're back with another batch of stories, thank you, and we will see you then.